I got my genetics, I'm MTHFR, I took methylfolate, I took B12, and now my heart's racing, I feel lousy, and I'm like, right, you can't just jump into, there's no shortcuts to this. And so, there's a whole group of people that are just teaching, if you have these SNPs, these single nucleotide polymorphisms, these changes in your genes that makes them function maybe not quite as well as they should, that if we just load you with extra nutrients, that they're gonna, all of a sudden, everything's gonna work and do better. But that's really not the way it works. And more often than not, when people do that, they wind up actually worse off than they were before.
Welcome back, everyone. It's Mike Mulzel here with HighIntensityHealth.com. Thanks so much for tuning in. We're live here with Dr. Eric Balcavage, and we're going to talk about methylation. So he's an expert in this area. He's a chiropractic physician in the Pennsylvania area. And as you can see in the whiteboard, as he starts talking, he geeks out with this stuff. And so he's going to break it down for us and help us understand this complex topic of methylation. So Dr. Eric, thanks for being here.
Hey, thanks for having me, Mike.
Love it. So let's kind of talk about, before we talk about your backstory, you have this great whiteboard that's loaded with all kinds of pathways. Tell us what that is.
So behind me is what I call a methylated life. So I didn't really know too much about methylation, but my focus in my practice is on helping patients with chronic conditions. And we work with the basics, autoimmune diet and leaky gut, and work with those stuff. But some of my patients were really just struggling. I didn't know what was going on. And somebody walked into me with their genetic profile and said, "Hey, I got this MTHFR thing. What does this mean?" And I was, I don't know. And so I started Googling it. I looked up, Googled MTHFR and methylation, and I saw Ben Lynch's kind of pathway planner and Amy Yasko's stuff. And I was like, holy cow, that seems like a lot of work. I'm putting that away. And I put it away for a bit, but I realized I needed to come back to it. I found Ben's informational videos on his site and started taking his coursework, and he's really been a huge mentor. I pestered him quite a bit with lots of questions to try and fill in the gaps of what I didn't understand. And then as I started applying it in my practice, I started seeing patients really change and improve. Not for about 80% of the patients that we'd see, we'd help them. You clean up their diet, you clean up their nutrition, you get their gut working better, and they get better. But there's that 20%, and that 20% is growing, who, no matter what they do dietarily or do to work on their gut or exercise or thought process, they still didn't improve. And that's where we really need to dig into those methylation processes a little bit. Mm-hmm. So started working with that with my patients, and then I started my fellow docs and peers in my functional neurology and functional medicine groups were inquiring, okay, what are you doing, and how do I understand it? So I started teaching some seminars on methylation to instruct them. And then I realized they were getting it, and they were starting to learn it, but they were starting to jump too quickly into the genetic SNPs and saying, okay, what's the SNPs and how do I treat the SNPs? So I then said, okay, I got to back this up a little bit and started what the principles of what I call a methylated life. And that is, if we live a better life, we kind of fix our methylation without a lot of extra work. So we kind of came up with these principles, and those, I call them the fitness factors. And we need to understand genetics and epigenetics. So I think understanding our 23andMe panel is important to understand what the possibilities of problems may be, but those are just possibilities. Epigenetics and how our diet and lifestyle plays on those genetic SNPs is probably the bigger issue. And so the rest of those methylated life principles are, you got to have dietary fitness. So what you eat makes a huge difference in how healthy you're going to be, your vitality, and your methylation processes. You got to have emotional fitness. So what goes on between the 6 inches of your ears makes a huge difference. And patients, really, sometimes that's a struggle for them to realize that how can that have such an impact on my health and well-being? But you know as well as I do, if you're constantly stressing yourself out, you're chewing up your methyl donors. I mean, you're exhausting it. And if you're using all those methyl donors to make and process neurotransmitters, you don't have that left to make energy. So big factor there. So we work on our patients for their emotional fitness. Then we work on physical fitness. And I know you're a big fan of physical fitness, but you've got to be fit. Being fit, whether it's good posture, good movement patterns, strength, and and cardiovascular system fitness is all key. We then talk about sleep fitness, and sleep's huge. I mean, if you're not sleeping and getting quality sleep, you can't heal and you can't repair. I know you had one of the docs on earlier was talking about cortisol and the effect of cortisol resistance and catabolism versus our anabolic systems. And if we're not sleeping, we're not repairing. And that's really when a lot of the methylation processes really occur. So we talk about that. We then talk about brain fitness, and you got to have a healthy brain and healthy neural system to have a healthy methylation processes, and methylation plays a role in those. And then the last is you got to have metabolic fitness. So you've got to have good blood sugar physiology. You've got to have a good gut. You've got to have good immune system health. And so working through those metabolic processes and supporting those is really important. But those are the principles I'm now reaching out to try and teach my patients, and also teach the docs that I teach all the methylation pathways that Dr. Ben Lynch has nicely outlined in his planner, but understanding not just that, but how diet and lifestyle plays into that.
Gosh, beautifully said. And I think that's really important for everyone to understand that, these methylated, and you call them SNPs, and I'd love for you to break that down a little bit, but these small aberrations in our genes, if we try and correct those with micronutrients, that's a nice step in the right direction. But if I heard you correctly, we also need to work on all these aspects, from the thoughts, our emotions, reducing stressors, improving physical fitness. That's a huge foundation. So what I see a lot of people just jumping into the SNPs and thinking that, okay, I don't need to work on all this diet stuff. My problem is that I have MTHFR, so I'm going to take activated B12 and activated folate, and everything's going to go away. I don't need to worry about sleep. But that's not the right way to go. Is that what we're saying here?
Yeah, that's exactly right. And even I can't tell you how many docs that I've talked to who've said, "Hey, I got my genetics. I'm MTHFR. I took methylfolate. I took B12, and now my heart's racing. I feel lousy." And I'm like, right. You can't just jump into it. There's no shortcuts to this. And so, there's a whole group of people that are just teaching, if you have these SNPs, these single nucleotide polymorphisms, these changes in your genes that makes them function maybe not quite as well as they should, that if we just load you with extra nutrients, that they're going to, all of a sudden, everything's going to work and do better. But that's really not the way it works. And more often than not, when people do that, they wind up actually worse off than they were before. Those are the people that come in with bags of supplements to my office and say, "Hey, I'm doing this methylation stuff and I got all this stuff, but I'm not feeling any better." Well, let me take all that stuff and let me throw it in the trash, and we're going to start over. And we're going to start with the basics. And people that wind up going off to see somebody and get support, if they don't start with the basics, the people usually don't have the success they were hoping for, and that's the shame.
Wow. Great information. So you said that a lot of the methylation reactions occur at night. So let's maybe define what the methylation reactions are and why do they occur at night and what happens at night?
Well, when we think about the body healing and repairing during the day, that's at nighttime is when our body's going to do all that repair processing. So we definitely need to have quality sleep. During the day, our body's really in a breakdown process, this catabolic process. And so if we get good quality sleep, then those healing type reactions can occur in the body. Methylation is critical for our cell membrane health. So if we're not sleeping, we're not resting, we're not repairing, how are we going to build healthy cell membranes? Does it really make sense to try and heal a leaky gut if you're not going to sleep and allow that repair process to occur? I think not. So, but sleep is it's critically important. The caveat, I guess, or the problem is that so many people with health issues struggle to sleep, right? So we got to work on improving their health and improving their sleep quality so they can get to sleep. So we've got to work on that. But by far, most people, if they just did some basic things to improve their sleep fitness, they'd probably sleep better. So provide the environment, right? Are they sleeping in a dark room? Do they have miscellaneous lights on that they could get rid of? Do they have their electronic equipment and their alarm clock with the light flashing right near their head? Is their cell phone plugged in right next to the head that's disrupting their sleep? Do they have a night light on, so in case they have to get up in the middle of the night to go to the bathroom? Are they watching TV or on the computer or on Facebook, just before bed, which is creating more stress? Are they active enough during the day to actually create sleep pressure, right? If they're not creating the sleep pressure and the chemicals, and what I mean by sleep pressure, I'm sure you know those principles, is the activity and the things we do during the day produces chemicals that help us promote sleep. And so the people that are more physically active increase chemicals like adenosine, which actually helps promote tiredness, fatigue, and puts us more into a sleep pattern. I tell patients all the time, I said, I'm just too tired to exercise, or they have challenges with sleep. I always ask them, if you could remember a day when you slept the best, what's the day when you slept the best? And they'd usually say, well, it was a day when I was outside working all day, doing yard work. I came in, I slept really good that night. Right. Because you were physically active. You created sleep pressure. You produced chemicals that actually drove you to need to sleep and rest and recover. Most of us aren't active enough. So I'm sure I got off target here somewhere, but improving sleep quality is important, but there's things that people can do without melatonin, without all the supplemental stuff, if they just maybe lived a better life in simple things.
Yeah, that's great. Awesome stuff there. So we're methylating at night, and let's kind of just geek out a little bit. It might be a review for some of our listeners, but others are thinking, okay, well, I hear methylation, but what does that really mean? So maybe let's talk about methyl groups versus acetyl groups and go down to the epigenetic level and talk about gene activation and kind of what that is, just maybe for a few minutes so that we're all on the same page when we talk about these SNPs and then the effects that may have on our mood and biology.
So I guess what is methylation, I guess, in the first place? So methylation is the process of transferring a methyl group, which is a carbon and 3 hydrogens, from one substance to another. And essentially, these methyl groups or these methyl donors are like keys. They turn on and off processes in the body. So we need these methylation groups to make enzymatic reactions occur, to make our turn on and off our genes, to make and degrade neurotransmitters, to process our hormones, to make creatine, to help make ATP, to help make our cell membranes. So we need these methyl donors and these methylation processes to do hundreds of different reactions in the body that occur, billions of times per minute in trillions of cells at every moment. It's constantly going. So it's really an important process. But simply, I think, and I try and get my patients to understand, it's simply these methyl donors. Just think of keys or switches. If you don't have methylation working appropriately, you don't have the keys to turn on and off the processes in the body. And the quality of your methylation really determines the quality of your health and the rate at which you degenerate, right? We all get older at the same rate, but we don't all age at the same rate. Some of us degenerate faster than others. And I would say that that's based on the quality of our methylation processes.
Yeah, beautifully said. I love that. So to kind of take it one step further and talk about these SNPs, or these single nucleotide polymorphisms that are so hot right now, MTHFR, MTRR, there's SUOX, there's CBS. I'd love for you to expand on that. But what we're saying is if we have one of these genetic SNPs, these keys are not as effective as a normal key would be. So these processes, the dimmer switch is turned down a little bit. And so that may manifest in depression, malaise, fatigue, migraines, obesity, whatever it may be. There's all these slew of conditions. So maybe let's kind of tackle the common SNPs and maybe misconceptions and, information that you like people to understand about these SNPs and how they can overcome them should they get genetic testing.
Well, the big thing with looking at SNPs, obviously MTHFR is probably, I'd say, the one that most people know about, right? I mean, Dr. Lynch made kind of made his thing on MTHFR, and it was great, and we know a lot about it, but it's not the only one. But we definitely have people that say, "Hey, I've got MTHFR. What do I need to do? Do I need folate? Do I need B12?" Well, MTHFR is just one of a lot of SNPs that can be involved in the methylation cycles. But MTHFR is a common one, and it plays a role in the methionine cycle and especially in the production of creatine and energy. But it also plays a critical role in neurotransmitter production. So if MTHFR is compromised, we can have the potential. I say the potential for decreased function, because depending on the type of single nucleotide polymorphism, if it's homogeneous, like we've got two bad SNPs or two bad genes there, we can have more of a deficit in the way the enzyme works, versus if we have a heterozygous defect where only one of the genes is compromised. So when there's a compromise in the system, I think it's important for people to know, just because you have the SNPs doesn't mean you necessarily have to treat something. I think you need to take into consideration how somebody's functioning. I'm 6'7", 1298, compound heterozygous. Does that mean I need to be supporting folates and B12 all the time? No, I feel pretty good for the most part with minimal types of supplementation. I don't have to do much. Do those SNPs rear their ugly head potentially? Yeah. As an endurance athlete, yeah. When I'm pushing the bounds of the capacity of my tissues, my Raynaud's will kick in and I'll have some problems. If I do a better job of supporting my physiology and not just folate and B12, but the rest of the cycles, maybe I never even realized any of those potential challenges with things like Raynaud's or any other autoimmune issue. But MTHFR is really important. There's definitely MTR and MTRR, which affect B12 recycling. Those are common SNPs I see quite a bit. CBS plays a big role. I think not as big of a role as some were thinking. Especially in the autism community, I don't see necessarily the correlation that I read quite a bit about. At least in the general population, it may be a bigger impact in the autistic community. SUOX, which is a gene or an enzyme that's involved with the clearance of sulfites, I do see that quite frequently. It's classic when I take care of a lot of women and men with hypothyroidism, especially Hashimoto's, and it is a common question I'll ask if they have a problem when they're drinking red wines, and yeah, they'll be like, "Hey, how did you know that?" Yeah, so SUOX is one of those things that's really, really common. It's funny, I have SUOX. My son's lucky enough to have SUOX, but I didn't really get into the genetic SNPs with my 18-year-old. But he was going to one of the Brazilian steakhouses for a feast with his college buddies. And he's texting me the whole time he's there. He's eating like a champ. He's got the meat sweats going, and he's just having a great time. And the next day, he called and said, "I feel like I have the worst headache ever." Right? And he's like, "I don't understand why." I'm like, "I'll tell you exactly why. Your dad gave you some good genetics. You couldn't clear all the sulfites and sulfates from all that process, all that meat that you were eating the other day." I said, "Next time you go, let me know, and we'll load you up with a little molybdenum to help you clear that stuff." But there's a huge, huge impact that you can have. But again, that's the extreme. He probably wouldn't have known about he probably wouldn't even considered the SUOX gene had he not had a dad that knew about methylation. You better get me back on track, Mike.
No, this is good. This is really good. That's very practical. This is a common thing that people experience is sensitivity to various food substances, and the knee-jerk reaction. And I admit that I would fall into this. Is you have a histamine issue, so diamine oxidase, the enzyme that breaks down environmental histamines, from food and produced by bacteria and so forth. So, how does that come into play? I think they're probably working together potentially, but love to hear your feedback on kind of this connection between SUOX and maybe histamine overload.
Well, definitely histamine overload is a huge issue. Anybody who's got gut issues, we typically start to see some decreased levels of DAO anyway. I think Dunwoody Lab does a nice panel that we can get some results from that, but I see quite a few people who have histamine challenges. There's quite a few people who have the histamine SNP or the SNPs that affect histamine breakdown. So that's kind of a tough mix to have together. If you've got gut barrier compromise, you're going to have decreased DAO production anyway. If you have the SNP, that's going to decrease your ability to break down histamine. So your foods have histamine and histidine, and they promote histamine production. And so if I have a SNP defect, I'm going to have increased histamine response. And if I have gut physiology problems, especially leaky gut issues, I'm going to have decreased DAO to break that stuff down. So I see that it's more common than I think most people think it is. The problem is, for those that do know, if you look at the foods that have, if you look at somebody who's got histamine intolerance, and you look at the foods that are high histamine, they're all the good foods. I mean, you're looking at foods that are the foods we really want them to eat, right? So we're looking. So you tell somebody, I think you've got what you're having is a histamine sensitivity. And they're like, okay, let me look up the histamine intolerant foods. They're like, I can't eat anything now. You already put me on this anti-inflammatory kind of, I call it a paleo-inspired diet, but it's really, I don't really care if somebody's vegan, vegetarian, or paleo or Mediterranean, as long as it's real food. But when we try to help somebody heal and repair, we definitely put them on an anti-inflammatory kind of paleo-inspired diet. And we do see some challenges if they've got histamine breakdown challenges. I usually use one of Dr. Lynch's products. He's got a histamine block support, and I've used that with quite a few patients, and it's a great product to use.
Yeah, that's amazing. Did you want to keep going on that thought? Didn't want to interrupt you. I thought you were done.
No. Go ahead. Okay,
yeah,
go ahead.
Perfect. That's great. So let's kind of tackle the CBS, cystathione beta synthase, I believe it is. So there's different aberrations, and I know this is big in the autism community, like you mentioned, but you don't see it being much of a problem. And we had Russell Jaffe on the show, Dr. Russell Jaffe, and his big thing was supporting sulfur metabolism. So he every day has, a lot of garlic, onions, eggs, I think turmeric. I mean, there's a couple of different other, phytonutrients and sulfur-rich real food. And so he thinks that's, instead of making them condiments, his vernacular was make them staples in the diet, make these sulfur-containing food staples to support detox pathways. And I sent this out to our email list and got a lot of great feedback, but a couple of folks wrote back, not with people with CBS. You can't give them that. Quercetin you can't do. And so I didn't even want to go there and start arguing, because honestly, I don't feel that comfortable, going down that road. But it seems kind of counterintuitive to me that we should avoid these sulfur-containing foods, even if you do have some genetic aberrations. But maybe I'm thinking wrong here. So you're looking at the whole picture. Where does CBS come into the picture and sulfur foods, and what's your perspective?
I think the sulfur foods are important. I mean, it supports detoxification pathways. It supports glutathione production. We need to use that pathway. I just don't see the correlation between the people that have CBS and this overflow down that pathway creating a problem. Obviously, if somebody's got SUOX issues, that could potentially be an issue. But I just don't see it. And maybe because I'm in a different pot of people, but I just don't see it. I've tried looking at it a bunch of different ways. I've talked to them about it, and I think CBS can potentially be a problem, but I don't think it's as big of a problem. I see more people with CBS SNPs and they can't clear down that pathway than CBS being this upregulation and really flushing things down the drain. I really don't see it that way. I'm not sure if that answers the question or not. I think it may be a little bit blown out of proportion.
Yeah. Okay. So what I heard you say is don't make a big deal out of sulfur-containing foods. And so keep eating your garlic, onions, eggs, whey protein, turmeric, resveratrol, things like that are going to support that pathway, because we need glutathione. I mean, that's a situation. I mean, it's the most abundant sulfur-containing compound inside our cells. It's great for detoxing and all that. And so fantastic information. Now, let's maybe some other aspects of related to folic acid. We know that, kind of break it down for us. We know folic acid can kind of competitively bind to proteins and cause these challenges with the real MTHF. Again, I'm not an expert on this, but break it down. Why should we avoid folic acid?
Well, folic acid is obviously it's synthetic, and I run quite a few methylation panels, and what we see pretty consistently is people with high folic acid levels, but their RBC folates, that means that's the folates that are actually inside the cells, being woefully low. I can't tell you how I've run a ton of methylation panels, and I don't know that I've found anybody who's I don't run them on typically healthy people, but I run them on chronically ill people, and they're all deficient. And so they're all on, a lot of them come in on folic acid. Their folic acid levels are in great shape. Their doctors are telling them, hey, you actually have high folic acid levels. You don't need folic acid. And yet when we run an RBC folate, we find that it's not actually getting into the cells and doing much. So folic acid actually can actually bind to the folate receptor sites and actually clog them up. I think if you think of like if you think like a nightclub, right? All the commoners are the people kind of packed outside the door wanting to get in. And if folate is the celebrity and folic acid is all the commoners, they can't get through the crowd to actually get into the cell. So you can have plenty of folic acid on board, and you could be eating tons of greens, but not actually getting the natural folates from those greens into the cells to actually do much good, because the receptor sites are so clogged up. And what we've also seen is when the receptor sites are clogged, then we've got lots of folic acid around, then we kind of downregulate those folate receptors, so it creates another issue. If you clog the receptor sites and then you downgrade and you have fewer receptors, it's like having fewer doors to get into the club. So it makes it even harder. So people wind up having these high folic acid levels and yet significant folate deficiencies. And folic acid actually has to be converted into methyl tetrahydrofolate to really be usable in the body. And so just giving folic acid doesn't necessarily mean it's going to do what we think it's going to do. It actually has to go through some steps, and that MTHFR enzyme is one of those steps it has to go through to get to that final step to become methyl tetrahydrofolate.
Wow, great info. So basically, to break that down, you can eat the best diet and get all these natural forms of natural folates that will support methylation. But if you are getting either supplemental or food fortified folic acid, that can negate a really healthy diet. So basically, we want to get that out, of your supplements and avoid foods that are supplemented with folic acid, because that's not a good thing. So, and you'll be surprised. I mean, Dr. Eric, I'm sure, you probably order a lot of different professional brands, and we still see folic acid used in all these different brands that have good reputations. And it comes down to a cost issue, or they haven't made the switch yet for who knows what. So, I think that's important for everyone, no matter, even if you trust the brand that you're using, check to see and look to make sure it doesn't have the folic acid in there. So fantastic info. Now, any other SNPs that we should be aware of? And maybe we can kind of talk about some B12 related SNPs, because I know that gets kind of fun and complicated, and maybe we can simplify that for people.
Yeah, I think for the B12 SNPs, we're definitely considering or taking a look at MTR and MTRR. MTR, thymine synthetase helps recycle, or it helps take the methylcobalamin and convert it and use it with that methyl tetrahydrofolate. One of the big challenges is that if there's a defect there, then we're not as effective at using that methyl tetrahydrofolate. And there's a couple different things that can kind of inhibit. So we can have a SNP that inhibits that enzyme from working. We can have inflammation that can inhibit that enzyme from functioning. We can have some elevations of nitric oxide that can inhibit that enzyme from working. So there's multiple things that can affect that methylation, that methylcobalamin from really doing what we really want it to do. And then there's MTRR, which really inhibits the recycling of the spent cobalamin back into methylcobalamin. And we see both of those. I see those quite frequently, where a person has one or both SNPs there, and so they have pretty compromised ability to make or recycle the methylcobalamin on their own. And so sometimes in those situations, we have to support them with methyl B12, and in other situations, we have to use other forms, hydroxy B12. Sometimes if they've got some challenges at MTR, maybe some adenosylcobalamin as well if they've got some mitochondrial issues. So it's not just as simple as just loading up on methylated B12. It's understanding what your patient's reaction is when you give those things, and understanding their history to understand, should I really be giving somebody methylated B12, or should I really start them off with a hydroxylated form or an adenosyl form? A good test to use is an organic acid test. You can get some indications of whether adenosyl B12 may be a better place to start versus the methylated B12.
Share with us maybe those biomarkers, just in case people do that.
So organic acid test is a urine test, and we're looking at FIGLU on there. And so methylcobalamin has to be converted into adenosylcobalamin inside the mitochondria. If somebody's got energy production issues and they're tired and they're fatigued, and we see an elevated FIGLU on their organic acid test, that's a patient that I'll probably be starting them with adenosylcobalamin first, so that way we can then support their production, support their energy production systems, especially Krebs cycle. So we'll start with some adenosylcobalamin, get the ball rolling, get their methylation cycle kind of kicked into gear a little bit before we try supporting them with the methylated B12.
Love it. So for people listening that haven't had their genes tested and they want to just, optimize their physiology, athletic performance, mental clarity, and so forth, would you suggest it's probably safe that they would, if they don't know their genes, just to be sure, start out supplementing, maybe low dose, just to make sure they're getting it in their diet? Maybe they don't eat meat and so forth. Hydroxy B12 instead of the methyl B12. Is that what we're saying?
You know what? I'd say no. I'd say that for the vast majority of people, I think the best place to start is if they're going to start with some type of supplementation. I think almost everybody could benefit from some type of a good quality multivitamin. I mean, we talk about eating real food as a good place to start. More whole food, organic food, if you can get it organic. If it's local, start there. Eat better food. Step 2, because of the quality of the soils that we grow stuff in, stuff doesn't have the same nutrient quality maybe that the internet says broccoli should have this much nutritional value. Well, I'm not sure where that number comes from anymore, because it really depends on where that broccoli is grown, how it's grown, pesticides, everything else that's in it. But we want to eat real food and then take a good quality supplement. And I would still tell my patients to use a high quality multivitamin that's got methylated B12 and methylfolate in it, not folic acid, as a start. If they have a reaction to that, then I would pull back. If they say, hey, I'm not feeling well since I've been using this multivitamin, then I'd maybe start pulling them back and say, okay, let's take a look at what's going on. But I would still start them with the methylated form, because that's the most usable form in the body. And I would start with that. I wouldn't, in a multivitamin form, you're not mega dosing it. So you're going to get a dose that I think the vast majority of people can manage. But if they have a challenge with multivitamins, or they come in with a history and saying, hey, I can't take multivitamins, maybe take a look at what quality they were taking, what type of supplement, what the ingredients were. Was it folic acid? Was it cyanocobalamin? Maybe not methylcobalamin. Was there gluten in it or soy in it? But I think in the most part, starting with a good quality multivitamin that's got folate and methylcobalamin in it, I think almost anybody could start there.
Mm-hmm. Yeah, great point. And as you were talking about that brought up a study, I think in 2011. They keep doing these reviews on these, cohort studies where they track individuals that have been taking multivitamins, and this is not an interventional trial. One of them was published in the Archives of Internal Medicine and tracked multivitamin consumption with various diseases. And what they found was that the title of the study says multivitamins cause cancer, but if you actually break down and read the study, they break down the different micronutrients that people are taking and add a p-value that will say that consumption of that micronutrient is linked with cancer, for example. And if you look at it, the p-values were positive only for iron, and folic acid, incidentally. And so, I'm curious to see if B12 was in there. So we know that, just make sure when you're taking your multivitamin that you're getting these active forms, and probably for men and non-menstruating females, that the iron probably don't need to take. But so let's talk about forms of B12. That a lot of multivitamins, the junky forms, have cyanocobalamin. And where does that play into this role? Does it affect binding like folic acid does, or?
I think the biggest issues or arguments that you have for cyanocobalamin from the health perspective is, why do we need cyanocobalamin in the first place? There's methylcobalamin is the usable form. Why aren't we just giving methylated cobalamin? Or adenosylcobalamin or hydroxycobalamin? Why don't we just give those? Why do we give cyanocobalamin? And so I know it's less expensive, it's cheaper to make probably, but the argument against it is, what do you do with that cyano group? It's not, the cobalamin part is really the important part, but the other important part is, what's that cobalamin attached to? And does that piece that the cobalamin is attached to, what does it do in the body when it gets in there? I think most people don't take into consideration, well, if I'm just taking B vitamin, it doesn't matter the form of it. If I'm taking B12, it doesn't matter the form. But what that B vitamin is attached to does make a difference. What does the cyano portion, what is that going to do in the body? Does it do anything positive to the body? And the answer is really no, right? We now need to take this. We have the cobalamin, great. But now we've got to get rid of this cyano attachment, which requires energy to get rid of. So in the process of trying to increase energy by giving a methyl group, right, by giving B12, not a methyl group, but by giving the B12 to support methylation, we now got to take energy that we're trying to create to get rid of this byproduct of the supplement, when we could have just given a better form of it. If we give a methylcobalamin, the methyl group can do something. If we give adenosylcobalamin, the adenyl group can do something. If we give hydroxycobalamin, the hydroxy portion can do something. We give the cyano portion, it doesn't really do anything except create a toxicity issue potentially. So I try and get patients to stay as far away from that as possible. But I have patients that they'll say, hey, my doctor said it doesn't really make a difference. Well, okay, but I'd argue the other way.
Yeah.
And if it doesn't make a difference, why not give something that actually does something beneficial versus something that has really no benefit?
Mm-hmm. Yeah. Why rob Peter to pay Paul when you could just, pay Paul by taking either the hydroxy or the adenylyl B12. So, or the methyl B12 instead of the cyanocobalamin. So I have a backstory on this. So the raw material supplier that supplies Zymogen and Seeking Health with their methyl B12 is a company in Spain called Ferrar Health, and they make the highly purified methyl B12. And so I had a conversation with them. So here's the backstory on the raw material side of cobalamin. So basically all these, supplemental raw material ingredients are derived from bacteria. So they'll have a bacteria that will make cyanocobalamin. And basically a lot of companies will just buy that raw material because it's the least effective. It takes the least time. Now, to get that cyanide group off of the bacterial fermented B12, you need to cause a methylation reaction, which is usually utilized. There's benzene and toluene and various, persistent organic type pollutant compounds that are needed solvents to get that off. But this company uses a CO2 extraction, so it's pretty labor intensive, if you will, and it takes energy in the lab to actually do this. So that's why a lot of companies will utilize the cyanocobalamin, because it's very inexpensive. The methylcobalamin is very expensive, but it's a great material and helps people in a lot of different ways. And one of these things that you can't really get from a lot of food sources, particularly if people are not eating clean protein and so forth. So I love that story, robbing Peter to pay Paul. I'm going to use that next time, Dr. Eric. So as we kind of transition here to the final questions, anything about methylation or epigenetics or genetics or SNPs that we didn't talk about that you would like to share?
I think whether it's a patient or a physician who wants to start helping people support their methylation processes, I think the big thing for the physician to know is, if you're working on somebody's diet, if you're working on their helping them with their emotional fitness, if you're helping them with their sleep patterns, if you're helping them with their digestion and getting them off sugar and helping support better nutrition, you're going to improve their methylation. You're going to help just doing those methylated life principles. You're going to improve 80% of the people you come in contact with. And I think that's important. From the patient side of it, do those principles and you'll improve your health. Without even knowing what methylation is, you're going to start to improve your methylation processes. But because of the way we eat, because of the medications we take that affect methylation, because of so many other factors in our environment, we're starting to see that 20% of the population that was chronically ill, that percentage is getting bigger and bigger every day. And those are the people that we really need to dig deeper into the methylation processes and understand. And so as for the physicians, I think it's critically important to start to learn the methylation pathways. Ben's got a great planner on his website that kind of lays out the whole things. And in my seminars, I teach the same. I teach from that planner plus. So we'll go through the folate cycle, the methionine cycle. We'll go through transsulfuration. We'll explain urea cycle. We'll explain Krebs cycle and how all those things work. And it's important to know how all those cycles work, so that you can help some of these, and then you can help some of these chronically ill people by taking a look at their SNPs, understanding all those pathways. While it looks like this complicated mess, you're gonna need to know that as patients get sicker. And so for the physicians, even though it looks like a mess, get Ben's planner, start looking at that thing, start listening to some of his stuff, come to maybe my methylation seminar, really start to understand these concepts of methylation, how it plays a role. Because once you start to understand how methylation works and all these methylation reactions, the light bulb will start to come on when you start to listen to people and you go, oh, man, that's what's wrong with this patient. And you can help that 20% that really have struggled, the ones that have been to multiple functional medicine practitioners, the ones that have been to almost everybody I see has already been failed in traditional practice. But the people that have the real significant methylation problems and the combination of SNP defects and other blocks within their methylation cycles, those are the 20% that I see more and more of. And so I urge the patients, the people, to live these methylated life principles: better sleep, better physical fitness, better diet. And for the physicians to the same thing, but really start to learn the concepts of methylation.
Mm-hmm. Great. Wonderfully said. And just wanted to highlight seekinghealth.org is Dr. Lynch's website, and he's doing a great conference in the fall in Denver. So for nutrition, fitness, or healthcare practitioners that are interested in kind of taking this to the next level, I think that'll be a great conference. And you're speaking there as well, I believe, on Saturday. Is that right?
I am. I'll be speaking. I'll do a case study presentation. So I'm looking forward to that. So that'll be really nice. Yep.
Cool. Fantastic. All right. So let's get into the nitty gritty here about what you do, Dr. Eric. So you're physically fit, running a great functional medicine practice. You have a bunch of kids. So let's talk about your morning routine. We know that the morning is a great time that we have control over. And so we're encouraging people to, kind of do some healthy things. We want to get an insight into what you personally do every day when you wake up. So share with us what that looks like.
So I'm an early riser. So I rise between 4 and 4:15 each morning. I'll start the day with apple cider vinegar and water just to get the gastric juices and everything going. And then I'll typically have a cup of coffee. I do like my cup of coffee in the morning. Sometimes it's bulletproof coffee in the morning, but I definitely have my coffee in the morning. I have my little snack in the morning. I have what I call breakfast brownies, which are kind of paleo inspired, lots of nuts, spinach, and lots of good stuff in there just to start my morning. I will, while I'm eating and having my breakfast, I'll usually do some reading for about a half an hour. And then I start into the rest of my morning routine, which is I'll do some foundation exercises, which are essentially like yoga type moves. So I'll do three exercises 3 times, just kind of get my posture supported a little bit better. Then I'll sit down, do a little bit of heart math to kind of get my breathing and my heart and my neurology in sync. And I want to thank you for that, because I listened to one of the podcasts and wound up getting into the heart math and now using it for for part of our ADHD program with some of our patients. After I finish that, then I'll sit down with my journal and I'll go through things I'm grateful for, spend some time with that, kind of write out my affirmations, and then I'll take a look at my big three, which is my three big goals. And what are my three big goals, and make sure that I've got something listed out that I'm going to focus on that day to make sure I'm doing something to complete that. That'll usually take till about 5:30, and then I'm off to shower, eat, and get my kids up, get them moving, and then head off to work. And I head off to work with a Mike Mutzel High Intensity podcast on my 25-minute ride in. I do listen to it on 1.5 speed, Mike, so that I can get it done before I get there. So hopefully when I listen to me, I may have talked a little fast. I may have to slow that down to 1.2. We'll see.
I love it. That's a great routine and great tip, by the way, on adjusting the speed so you can get a lot more done in a short period of time. So that's how I listen to audiobooks. And for folks that don't know about audible.com, it's owned by Amazon. For $19.95 a month, you can get a book a month. And so it's a great way to just kind of keep up to speed on things. So you can take, an 11-hour audiobook and cut it down to 5 or 6 hours and listen to chunks at a time, or the podcast, like you mentioned there, Dr. Eric. So fantastic. I need to work on getting up a little bit earlier. I think 4:15, that's a great target. I'd be happy with like 5:30, but I tend to stay up late.
I'm not sure. My wife's always excited because by 9:30, I'm ready. I'm done. Right. The kids may still be going, but I'm spent for the day. So yeah, I'm ready for bed.
That's awesome. Great info. Okay. So let's talk about supplements here, or whole food ingredients. If there was just one herb, nutrient, botanical, or food substance that you just absolutely love and you wish most of your patients would take it, and if you were on a long trip, you would definitely bring it with you, what would that substance be and why?
I know it's coming. I would tell you from a methylation standpoint, I'm thinking creatine would be one of those things, but I would say for the general population, vitamin D has got to be at the top of the list from a everyday person supplement. It is rare that I'd say out of 100 blood labs, I'll see one person that has optimal vitamin D levels. And it's just woefully deficient. And so I think vitamin D would be number one. If it's for optimal athletic performance, I'd be taking my minerals with a little creatine in it, and I've got my bottle right here. It's my little Seeking Health optimal pH support. So I down a couple of those a day.
Mm-hmm. Yeah, I love it. And just to underscore, kind of the whole body effects that creatine has, there's so much for research on neurology and memory and so forth. I mean, it's great for everyone. So, and again, it's one of these things, if you're not eating high quality animal protein, you're probably not getting enough creatine, just like the B12 that we talked about. So something that we can definitely take. And I love the vitamin D. That comes up so much. And thanks for kind of underscoring the importance of that, and that, very few of your patients actually come in with optimal health, vitamin D levels, which we see even in practitioners. I just recorded a podcast with Dima Verna, and so she, I think lives in Clearwater, Florida, and she was the same thing. Basically every patient is vitamin D deficient from Colorado, Utah. I mean, it doesn't really matter. It's all across the country. It's kind of an epidemic here. So second final question here is, if you were to rub shoulders with President Barack Obama or a future president, and they turned to you and said, Dr. Eric, as a astute healthcare practitioner, a functional medicine practitioner, what sort of lifestyle or health tip would you want me to share with Americans so that we can cut our healthcare expenditures, improve the health and vitality of Americans? What would you say to him, and why?
I think we need to flip the switch. I mean, if we just ate more real food, we'd probably be healthier. So we subsidize people to eat junk food, and then we wonder why we're a sick society. And then we've got to subsidize the healthcare system because we've got all these sick people eating junk food that we essentially subsidized. So I would say if we want to improve the health and of this country, we need to really support better food and better nutrition. So instead of allowing somebody if they're impoverished and they're poor and they're struggling to make ends meet, and we're subsidizing their food intake, let's make sure that food that we're helping them buy is actually doing something good for them. Because if I don't have the money, or we think it's expensive to eat healthy, it really isn't. But we're thinking quantity versus quality many times when we don't have much money. How much can I buy for my $10 versus, what quality food? I mean, you could buy probably you could probably buy a big bag of chips, right? For a little bit less than you could an orange. Okay. And so which one are you going to get more value out of nutritionally? And which one's going to satisfy you? Probably the orange, but that big bag of chips and the soda that you got with it for the same price, that's more. So people, I think quantity more than the quality. But I think if we change how we subsidize basically how people can, what they're purchasing and buying with how we subsidize them, and then let's subsidize, instead of these big companies that are producing kind of all this grain-based product, why don't we start to subsidize the local farmer that's growing organic food? Why don't we do that? Because that's better quality food and better quality nutrition. I think it's pretty simple. We just eat better food, we become a healthier country. If we're a healthier country, we've got less sickness and disease to treat, and our medical expenses go down. I mean, it seems simple, and I know there'd be the argument, okay, who makes a determination of what good food is, and how are we going to explain it? I think you may have to dumb it down so much that, hey, if it's got a green sticker on it, it's good. That's good. You get full compensation for eating that food. You can use your money to buy that. If it's got a yellow sticker on it, you're only going to get compensated for that 20%. And if it's red, no subsidy is going to pay for that. I mean, you shouldn't be able to buy junk food with government supported money, or I don't know. I could go on. The whole thing irritates me, but I think that's where we'd be. We've got to change the paradigm of how we think. Instead of having big subsidized foods of grains and corn and all those things that we know are problematic, let's get back to supporting the local farmers and local raised food and organic farming, and we'll probably be healthier as a country and a nation.
Love it. That's great. Haven't heard anyone kind of articulate the perceived value of food in such a way. And I think that's something that, kind of pause and reinforce and underscore that, the perceived value of a bag of chips may seem like it's, going to feed a family better than a stick of broccoli. But the challenging thing with the broccoli is all plus, it's all upside. There's no downside. The bag of chips is not only costing you money and there's no nutrients in there, but it's probably going to make your health worse. So I love how, maybe putting those stickers and letting people know that, yeah, it may appear cheaper, but it's going to cost you more money in the long run, or it's going to reduce the amount of time and quality time that you have on this world, which you can't replace with money. So it's really important that people kind of understand that there's the negative associated with that, and it's only kind of positive health effects with real food. So great info. So Dr. Eric, I'm sure our listeners are going to want to reach out to you, learn a little bit more about your work, and you have a couple of books coming out. So let's talk about the websites and best online resources where people can reach out to you.
So I have a website called themethylationdoctor.com, and that's primarily kind of geared more towards physicians, but anybody who gets to that site can also find our other site that's being developed, that's generated more towards the general patient or person, the everyday person, which is called amethylatedlife.com. My practice is glennmillschiropractic.com, so I can be found at any one of those three websites. I'll actually be teaching a methylation course coming up in the end of July, beginning of August. I call it the Methylation Madness Seminar. And so we spend 20 hours going through all of the methylation pathways and explaining those, and using a lot of case studies to help the docs understand what's going on and how to treat. And then I'll be is it September or October?
It's October 13 or 14. I'd have to look at it. Yeah, seekinghealth.org has that info for Ben Lynch's seminar.
Yeah, so we'll be out there, and you're the MC or the host of the seminar,
guess,
right?
Yeah, he invited me to do that, and I couldn't turn it down. So I think part of that stems from one of his first conferences he did at Bastyr. He asked me to do an introduction. And so that was like his, first big conference, and it was a major success. And so he asked me to MC this one, which I've never done before, a whole conference. I've introduced people. So it's putting some pressure on. So I got to work on my skills a little bit here.
I'm sure you'll be fine.
Yeah, it'll be fun. So awesome, Dr. Eric. So thanks again. And for folks listening while you're exercising or driving, I posted the show notes and the video if you want to watch this video interview at highintensityhealth.com/Dr. Eric. So, and that's Eric with a C. So Dr. Eric, thanks again for joining us, and hope you have a great day and a great weekend.
Thanks, Mike. Thanks for having me.